Welcome to Layer 1 with Vijay for episode 3 on how machines learn to read. Here we explain the complex technology in a simple manner. In the last 2 episodes, we have covered the GenAI evolution right from data science to the current agentic AI, where we have seen one beautiful example with a single prompt: book the ticket during my free time. It has taken 4 actions automatically. We did not stop there. We learned how machines actually learn. In that, we have seen the handwritten number. It gets into the neural network, then it predicts some number. Instead of 3, it predicts some 7. Then it has find out the error, then it has gone back and adjusted those weights, and finally after many repetitions it has produced the correct number. So that is how machines learn. In this episode we are not stopping at the numbers, we are introducing the sentences and words. We will learn deeply about the NLP pipeline, that is natural language processing. The various 4 steps we have mentioned here, those are going to be covered in depth. That is, first one pre-processing, second one vectorization, third one modeling, finally fourth is inference. Let us understand the problem. On Monday 9 a.m., you just opened your inbox. There are 16 emails waiting for you. One from Priyasha, refund request. I was charged twice. Carlos, Wi-Fi disconnects every 10 minutes. Daniel is having charged twice issue. Let us say you have a big company managing and you have one help desk email. Daily you are receiving hundreds and thousands of email from the customers, and you have a support team, but there is a dedicated team, one for billing, one for refunds, one for networking, one for invoice related. How one person can categorize all these things? Inhumanly, it is not possible. Here we are seeing continuously you are receiving emails. Currently it is not categorized. Let us see what happens once it is categorized. These 16 emails auto routed and inbox is 0. If this kind of categorization, if it is done for thousands or 10,000s of emails we receive on a weekly basis or monthly basis, it goes to the right team. Here you can see the replay once again. We are receiving the emails continuously. Currently it is not categorized. Now we have turned on the natural language processing. You see on the left side how automatically these are being routed to the respective folders. Human agents also, that is AI routing. Instead of manual triaging of 48 minutes, it has done in 4.8 seconds. That is the biggest advantage of this categorization. But how it is able to do it? It is happening because of these 4 steps. First one is pre-processing. Whatever incoming emails, it turns into the raw text. Second is vectorization. Because machines don't understand text, it has to convert into the numbers. We are turning the words into numbers. And modeling, this is the learn to separate categories. Finally, fourth stage is inference. Whatever new incoming email comes, it predicts. It's the same instinct we saw in the episode 2's training loop, that is predict, measure, adjust and repeat. Earlier it was just numbers, but now the numbers are not more. It is the words and text. Let us see the stages one by one. Here in the pre-processing, as we naturally predicted, customers write so many things in their email which are not required for us to categorize. We need to find out the keywords. Before that, we need to clean the text. One example, I am requesting a refund. My order number is so and so. In the first stage, that is pre-processing, tokenization. Here we convert each big sentence into individual basic units. Those are called words. That is, we call tokens. After that, we do the lower casing. This is case sensitive, so we need to lower case it, and punctuation removal and stop word removal. There are words and these are the punctuation or emojis will not significantly add to the email, like am, was. So those are the things which are not having any meaning. Those will be also removed. Then stemming and lemmatization. For example, in the email, just simply ran, running, but the dictionary word is just run. So instead of ran, running, we are again truncating into the dictionary and lowest word. That is requesting. In this case, converts into the request. Where we have started, we started with the 12 words. Where we ended, we just ended with 5 words. These are the 6 techniques. Strip the noise so the model see only meaningful words. This is about pre-processing. If we done it correctly, the later stages will be even better. This is the crux of the entire episode. That is the vectorization, converting the text into numbers. Because computers don't understand text, it can understand numbers. After that, it performs the mathematical operations on those numbers. Every word gets converted into a vector. It is like a numbers in a spreadsheet. We have numbers 1, 0, 3.4, 4.4, like that. Each number is associated with some word. There are 2 mechanisms. One is classical statistical vectors and second one is word embeddings. In case of classical statistical, we understand that it is simply count of the repetitive words. or frequency. In case of word embeddings, we are going one step further, trying to understand the meaning, even the not dictionary meaning. Let us see these two approaches. In classical vectors, we have two kinds. One is bag of words, another is TF-IDF. In bag of words, as you guessed correctly, it is simply counting words. Here what we do is we build a vocabulary. What is vocabulary? Let us say we have thousands of emails or tens of thousands of emails during training stage. We strip out all the unnecessary words and only the meaningful words only we keep. That is in the pre-processing. Then we have a dictionary of words like refund, money, network, slow, billing. These are not just 5. There may be tens of thousands of keywords that forms the shared vocabulary. Now a new email just arrived. I want a refund. Now what happens? From the pre-processing, it has a keyword want and refund. Now want is nowhere appearing in our vocabulary. Only refund is appearing in our vocabulary. This email belongs to refund. Bag of words simply count words from the shared vocabulary and converts email into numbers. Under classical vectors, we have covered bag of words. It is simply counting of words, but that is not enough. But not all words deserve equal weight. So to avoid that issue, we are entering TF-IDF. Here, TF-IDF asks two questions about every word, then multiplies the answers. What is TF? That is term frequency. In this, how often does this word repeat in this one document? Example, refund said 3 times in one short email. So it has refund so many times it is repeated. So it has a high term frequency. But that is not enough. If for example, please is repeated so many times, am is repeated, da is repeated so many times in the same email, that is natural. Now to avoid these things, we are using another terminology called inverse document frequency. How rare is this word across all documents or emails? Please, for example, shows up almost in every email. That will have low idea. But refund shows up in very few documents. Example, we are training in 10,000 emails or 1 million emails. In that, refund is appearing in only some 10 to 20 emails, but the, am, please appearing in almost 90% of the emails. Please, the will get the lowest score. So email 1 says refund 3 times. No other training email uses the word refund at all. So it has the high term frequency and high IDF because it is repeats a lot here in this email, but this is not repeated in any of the emails. So refund becomes a strong signal. Here you see the signal, high weight signal for this email. Now let us say some new email comes with I want compensation. Nowhere in our training sets the word compensation appears. So TF-IDF has never seen compensation, zero signal. It cannot tell this is a refund related, even though we know this is related to the refund compensation, but TF-IDF fails utterly here. So what is the alternate solution? There we are entering from classical vectors to word embeddings. We teach not the exact dictionary meanings. We feed millions of sentences and ask it one job: predict the neighboring words. Example, cat is an animal, cat is a pet, cat drinks milk. So like that we feed so many text related to the cat. Similar way, dog also we feed. Dog is an animal, naturally. It is not a car, it is not a truck. Dog is a pet and dog barks. Now you see cat appears near to animal, dog also appears near to animal. So this way it measures the distance, whether they are similar or not similar. One new word has come, compensation. Example, we have trained the refund, compensation, then naturally it understands that refund and compensation are closer to each other. We have covered first pre-processing, second is vectorization, that is converting the words into numbers. Now we are entering the modeling phase, that is the third step. Vectors are coordinates, just the numbers. The model just draws the boundary between these clusters. The final stage of inference, that is from vector to decision, automatically it happens. This is exactly what happened in the helpdesk inbox at the start. New email arrived, then it has gone through the all steps. The pre-process step, it has cleaned and tokenization is done. Then second, it has converted to the numbers, vectorization, either classical, TF-IDF or word embeddings. Then it applied to the model, linear SVC example that draws the clear boundary. Then finally it routed to the refunds team. So this is what we have seen in the before and after in our earlier email demo, in the live demo. Welcome to the live demo for the episode 3. Here we are going to show you exactly all 4 stages, how it is happening. Here in the text processing, I have given example, the cats are running quickly, aren't they? Now click on the run pipeline as we described above in the earlier slide. slides. First, tokenization is happening and lower casing. Here, everything is split into the tokens, including the punctuation, all the words. Here we started with 9 tokens. Then we are removing the stop words, which does not convey any meaning at all on their own. So we have removed here the are, aren't, they. Now remove punctuation also. What is left now? Punctuation. Then what we are doing is stemming and limmatization. Stemming means it is rule based, it is crude. For example, running. It can convert to the run, it can convert to the RUNN also, because it's a completely rule based. Now in the limmatization, we are doing based on the dictionary and root words. You see the funnel here, 9 to 3. This is about pre-processing. The vectorization. Here vectorization, as I told earlier, we have bag of words and TF-IDF. These are the classical vectors. These just simply counting the words. Now bag of words, thousands of previous help desk emails we received and we built one shared vocabulary. That vocabulary can be, you see, these are 10 we have shown here, but these are not 10 enough. There may be tens of thousands vocabulary will be there. And a new email just arrived. Refund my money. Now you see how it is calculating. Refund already in the vocabulary. So 1. And money, it is already available. It is 1. Oh, you see how vectorization is happening here. The raw email is converted into the numbers. So bag of words simply count words from one shared vocabulary and converts the email into numbers. We'll give one more example. Please refund my money. In one email, please, network is down. Here you see, even though we are trying to say it's a refund email and it is a network issue, but because please is repeated, so it counts please more number of times. This exact problem, how it is avoided in TF-IDF. TF-IDF, as we described earlier, how often a word appears in this email and how rare this word across all the emails. We have given please refund, please network down, please calls not working. So we see intentionally we did so many times please compute TF-IDF. In the document 1, you see even though please has come 2 times, because it has come in multiple emails also please, so it is given the less weightage and refund got more weightage. So this is the advantage of TF-IDF. And here also you see please got the lowest weight. In word embeddings, as we told that millions of text we are feeding and training, and you see here we got the vector space cat, dog, car, truck, puppy. I will start training. You see magically how the cluster will be formed. Cat and kitten are close together, dog and puppy are close together, and cat and dog are close compared to car, truck, bicycle. And car, truck, bicycle, they are close together. But in the real world, whether only these 2 dimensions appears? No, there will be 768 dimensions. There can be 4000 dimensions, means each word will be having these many features. Modeling here, you see here how neatly clusters are formed. Fit decision boundary here in the linear SVC, it simply draws the line and it categorizes left side into the refund and right side into the slow network issues. For example, we have the line new word compensation has come. In case of TF-IDF, it is unable to fit anywhere. It is neither refund nor the slow speed. But if you use the embedding, it is already embedding is converting that compensation into the refund side. So it is able to draw the line very well. The model sees compensation used like refund before. It lands right on the right side of the line, correctly classified. So putting it all together, inference stage, I want my money back. This delay is unacceptable. So here we are using vectorizer embedding and model linear SVC. We'll see what happens. So it starts the pre-processing. It converts into the vectorization to the numbers and model applied neat boundary. And finally it is predicted it is a refund. Same way in our earlier example, we have got 16 emails. Finally we have turned on NLP, does all these 4 steps. Finally it is predicted and has gone to the refund folder. So it is auto routed to the refund teams, matched refund relate teams. Exactly. This is about the demo. We now go to the presentation. Earlier we have seen bag of words has some issue. It is replaced by TF-IDF. TF-IDF has some issue, but still it has an advantages with the if I want exact word matchings. But if any new word comes, it is not in its corpus or vocabulary, then it struggles. The word embeddings resolve that issue, but still word embeddings fails in one place. In this example, we'll see that the same word, 2 completely different meanings. That is bank. I am sitting beside the river bank. Bank is edge of the river, right? The second sentence, I went to the bank to deposit money. Bank is here financial institution. But in case of TF-IDF or in case of word embeddings, bank has the single vector because it doesn't know which sentence we are referring here. Both vectorizers place bank in the exact same spot. So what is the solution? The solution lies in that 2017 magical paper, attention is all you need. What if the machines read the whole sentence, not just a list of words? Here sentence, the bank word depends on the neighboring words, river. In the second example, the bank led to the deposit. The same word bank, but the machine would weigh it against the actual neighbors each time, not a single fixed vector. That is exactly what transformers and attention mechanism do. That we are going to cover in the episode 4. That is the building block for the generative AI or ChatGPT or Cloud AI. Putting all ideas together from the previous slides, we started with one real problem of having so many emails that are unsorted, and we have sorted it finally using the natural language processing steps. These are the steps. We started with the incoming email. We have removed unwanted things and only the signal words we have taken. Then we have applied either classical or word embeddings to convert those words or tokens into numerical representation machines can understand. In case of classical vectors, we have bag of words and TF-IDF. This is simply counting the words. The new email we representing in the numbers. If TF-IDF it is going one step ahead, that is providing the weightage also for each word. We are not stopping there. We have gone into the embeddings where we have fed the machine with thousands or millions of text. It is able to find the similarity. It doesn't know the dictionary meaning of what is word cat and dog, but it can place these two together because it during the training stage it identifies that these two are appearing similar way. So that is about the word embeddings. Then finally the model is able to draw the neat line. Whenever new email comes, it is able to find out the label whether it is a refund related or it is a network related, because clusters are already found because of the neat vectors. Then it is able to classify whether it is a refund email or it is a network email. So that is about the inference stage. This is about the natural language processing. If you really like this episode, please subscribe. Every week we produce the new episode on the generative AI. The next episode is on the transformers. That is a building block for the generative AI and agentic AI. Thank you. Peace.